So, hi everyone. I'm very happy to be here. Thank you for joining with me. So my name is Kwon. I'm from Nokia Biola, France. Um, I am also contributing and working on the ODTN project. So since the beginning of this afternoon, you have been getting a lot of information about the ODTN projects, what we are working on. So in the talk, I'm not gonna reintroduce what the ODTN and what you are working on. Instead, I'm going to talk about how we use ODTN in our end-to-end network slicing concept. So, so what is the end-to-end network slicing? So simply is a network end-to-end network slicing contains the virtual and physical resources such as virtual BBU, BBU or the other component like SW gateways, Istega. It contains the transport slices, the run slices, and the core slices that are created by the 5G run controller and 5G core controller. One important point is a transport slice is not only the transport tunnels. It's much more than that. So what is the transport slice? So a transport slice is created by transport SDN controller. So basically it's a set of the connection between the VNFs, PNFs with the specific requirements in terms of latency, throughput, and reliability. So it's implemented by different technology from layer 0, layer 1, layer 2, 3 services over any kind of transport technology such as GMPNS, UDU, TU, DLUDN, and so on, multi-technology, IP, microwave, optics, and PON. In order to provision an end-to-end network slice, so we would need to have an end-to-end cross-domain service orchestrator. So in our research, we have developed a service orchestrator. So here is the workflow of provisioning of an end-to-end network slice. So at the first step, like the orchestrator receives end-to-end network slice request, is going to handle the request, extract the information, and decompose the end-to-end network slice into the network slice segment of the each network domain. So and then from that is generate the network slice template. Is it the deployment templates? Could be in Tosca YAML, JSON, whatever, depends on the implementation of your orchestrator. And then from that, you send the network slice segment request to each network domain, starting from the transport domain, from the run domain, and the core domains. So in this demo, I will be focusing on showing how we use ODTN to provision an layer 1 services for the between the run and the core cloud. So for that, we have a set of a test bed of the POC. So on top, we have the service orchestrator. So at the platform and services, at the edge cloud, we have a server that can run the 5G run services component, and at the core, we also have the 5G core services running. So just a reminder, the 5G here is the 5G emulator. So which is an let's say 9 based software reference implementation of the 3G, PP, 5G specification. So for the transport domain, we have kind of the multi-layer network. So we have the couple of open flow switch and two service router 7750. So but that this router are there for only doing the adaptation, because our transponders has only like 100 gig interface, so we need and the open flow switch support only 10 gig interface, so we have something in between to do the adaptation. So at the optical layers, we got a couple of transponder. We are the first step. We are going to we provision an 250 gig optical channel across to the our open light system. So this is the physical setup. So on the top of the left racks, you can see we have a couple of transponder. This is the two Nokia transponder PSI2T with the open config interface. On the right racks, you can see we have a open light system with a couple of router. So this open light system is under control of our ONS controller. So but since the TAPI interface of our ONS controller is under development, so right now there are no really communication between the ODTN controller and ONS controller. So that's why we have to provision an optical channel between the two light ports of the two transponders. So at the client side, we connect each transponder to the router, and from the router to the open flow switch. Each open flow switch is connected to the server for running the core server, what we call with its IP address, for running the 5G core services, and the edge for 5G RAN. We have another server that gonna host the ONOS and the service orchestrator. So those servers are just behind the racks. Here's the demo. So in the beginning we wanted to show the live demo, but then when we came here, we checked the VPN connectivity to our lab in Paris, and latency is very high, so we're not able to do the audio. So I decided to record video for that. So yeah, so with 10 minutes of the a video, so I hope it should not be the problem, step by step. And I cannot, moving forward, because if I click move forward, it's gonna move to another slide. So sorry about that. So here we I'm accessing to the ODTN controller. Yeah, with this IP address. That is 47, and we can see that the ONOS controller is running. So these ODTN application is activated, plus the other components like OpenConfig model, RESTconf, and so on. So we have 4 devices that are connected to the controller. 2 of them is transponder, and the others are the open flow switches. So from the ONOS GUI, Yeah. So it's so kind of multi-layer network. So on top you have two open flow switches, several server are connected to the switches, and on the bottom you have the our transponder. So go in more detail. We can see that the ONOS controller is able to discover the our transponder. We have 4 live ports and 10 client ports, 100 gig capacity each. So the client port connected to the open flow, which is port number line. Yeah, this is the view from the orchestrator. So that on top of the ONOS controller. So this orchestrator is developed in the context of the NGPass project. It's a European project. So we can see, here's take a bit time. Yeah. So so here you can see we have the 5G core components and 5G run component is already deployed and running. So all of the 5G run and core component is kind of the microservice based component. So it's all the components running inside the Docker container deployed by the Kubernetes, which is the container orchestrator from Google. So now we are inside the let's say the edge server with this the IP address that you were showing the previous picture about the overlap, and what I'm going to do now is to try to send the traffic from this edge server to the core server is on another side. So we're trying to ping from the edge that server to the other side. So you can see now, because there are no really the optical service in between the two transponders, so there are no really connectivity in between those servers. So to provision a layer 1 services from the orchestrator, so we are going to create a layer 1 services from the orchestrator. First, we get the service interface point of TAPI. So basically, we get the service the TAPI context. Topology context. So you have we have the two transponder corresponding with two nodes, node 0 and node 1. So in order to provision the layer 1 services, we simply just save and click, and it's gonna show the list of the service interface point of the each transponder. So we select the two service interface point corresponding with the each transponder and send the TAPI connectivity creation request to the ODTN controller. So from that, the ODTN controller going to send the configuration to the transponder, and we now should have the the connectivity between the core and the edge server. So yeah, so now we have the 5G core components running. 5G runs is ready. We have the connectivity in between the two RAN and the core server. We are ready to attack the 5G user to the 5G network. And the 5G user is emulated by a virtual machine that running the use-e project and stack. Yeah, it takes a little bit time. Yeah. So the attachment project is done. So now the user is ready to is connected to the 5G network. Right. So then the user can have the internet connection. It's go to Google, even streaming the YouTube video. Yeah, this is the emulators environment. In the reality, it should be much more faster than. So then, yeah, we try to let's say send some traffic to the internet. And then now we're going to delete the this TAPI services, the TAPI service by click remove. Yeah. So the request is sent to the OD10 controller, and the OD10 controller basically remove the configuration of the in the transponder. And now we from the client user, we don't have the internet anymore, and the connection between the two server is disrupted. Yeah, we can easier to just enable the connectivity again by sending a TAPI connectivity request, the creation request. Yeah, so the connection is off. So through the demo, we can see that the OD10 project is have the real implementation is working. You can just download it from the GitHub and try it. It's not something is in a slide. It's out there, and it works basically. And thank you very much. Any questions?
Any questions from the audience? So I have a question. So do you plan to take this further with the integration of the ONS when phase 1.5 comes in the project?
Yeah, definitely. The problem is, yeah, we would need a vendor with their transponder. They are willing to testing with our ONS. Yeah, because if we do the our transponder to our ONS is not really really makes sense. Okay.
There any other questions from the audience? Okay. If not, thanks a lot, Juan, for the.
Thank you very much.